The emerging process of 3D printing, which uses computer-created digital models to create real-world objects, has produced everything from toys to jewelry to food. Soon, however, 3D printers may be spitting out something far more complex and controversial: human organs. For years now, medical researchers have been reproducing human cells in laboratories by hand to create blood vessels, urine tubes, skin tissue and other living body parts. But engineering full organs, with their complicated cell structures, is much more difficult. Enter 3D printers, which because of their precise process can reproduce the vascular systems required to make organs viable. Scientists are already using the machines to print tiny strips of organ tissue. And while printing whole human organs for surgical transplants is still years away, the technology is rapidly developing. The mechanical process isn't all that complicated. The tricky part is the materials, which are biological in nature, said Mike Titch, editor-in-chief of 3D Printer World, which covers the industry. It isn't like 3D printing plastic or metal. Plastic doesn't die if you leave it sitting on an open-air shelf at room temperature for too long. The idea of printing a human kidney or liver in a lab may seem incomprehensible, even creepy. But to many scientists in the field, bioprinting holds great promise. Authentic printed organs could be used for drug or vaccine testing, freeing researchers from less accurate methods such as tests on animals or on synthetic models. Then there's the hope that 3D printers could someday produce much-needed organs for transplants. Americans are living longer, and as we get deeper into old age our organs are failing more. Some 18 people die in the United States each day waiting in vain for transplants because of a shortage of donated organs, a problem that Anthony Atala, director of the Wake Forest Institute for Regenerative Medicine and a pioneer in bioprinting, calls a major health crisis. An exciting new area of medicine. Bioprinting works like this: scientists harvest human cells from biopsies or stem cells, then allow them to multiply in a petri dish. The resulting mixture, a sort of biological ink, is fed into a 3D printer, which is programmed to arrange different cell types, along with other materials, into a precise three-dimensional shape. Doctors hope that when placed in the body, these 3D printed cells will integrate with existing tissues. The process already is seeing some success. Last year a 2-year-old girl in Illinois, born without a trachea, received a windpipe built with her own stem cells. The U.S. government has funded a university-led body-on-a-chip project that prints tissue samples that mimic the functions of the heart, liver, lungs and other organs. The samples are placed on a microchip and connected with a blood substitute to keep the cells alive, allowing doctors to test specific treatments and monitor their effectiveness. This is an exciting new area of medicine. It has the potential for being a very important breakthrough, said Dr. Jorge Reckler, a gastroenterologist at the Mayo Clinic in Phoenix and a member of the American Liver Foundation's Medical Advisory Committee. 3D printing allows you to be closer to what is happening in real life, where you have multiple layers of cells, he said. With current 2D models, if you grow more than 1 or 2 layers, the cells at the bottom suffocate from lack of oxygen. To accelerate the development of bioprinted organs, a Virginia foundation that supports regenerative medicine research announced in December it will award a $1 million prize for the first organization to print a fully functioning liver. One early contender for the prize is Organovo, a California startup that has been a leader in bioprinting human body parts for commercial purposes. Using cells from donated tissue or stem cells, Organovo is developing what it hopes will be authentic models of human organs, primarily livers, for drug testing. The company has printed strips of human liver tissue in its labs, although they are still very small, 4 by 4 by 1 mm, or about 1/4 the size of a dime. Each strip takes about 45 minutes to print, and it takes another 2 days for the cells to grow and mature, said Organovo CEO Keith Murphy. The models can then survive for about 40 days. Organovo has also built models of human kidneys, bone, cartilage, muscle, blood vessels and lung tissue, he said. Basically what it allows you to do is build tissue the way you assemble something with Legos, Murphy said. So you can put the right cells in the right places. You can't just pour them into a mold.